Example 4.17. A 10,000 used car is bought for 2,000 down payment, 14 payments of 500 ringgit, and a final 15th payment. If the interest charge is 9% compounded monthly, find the size of the final payment. So, for this kind of question, right, actually the payment is the payment made composed of several different kind of payment. Okay, so let's try to see one by one how actually we calculate this. So let's look at the information. 10,000 used car is bought, right, by paying 2,000 down payment. That is the first payment, and then the next 14 payments of 500, right? So 500 is the R because it is actually an equal payment made at equal interval of time. And lastly, the 15th final payment, right? Not mentioned here. So our job is to actually find out what is the size of the 15th payment if the interest charge is 9% monthly. Okay, so first we need to realize, let's try to see what is actually, how actually it looks like. So this is the timeline of the 15 payments. Okay, initially 2000 is paid, 2000 was paid, and then 500 for 14 times. Okay, and so as you can see here, 500 1 until 14, and then the final 15th payment is unknown, so we just put K there. Okay, so this is how it should look like in the timeline. So the question asks us what is actually the size of the final payment. Let's try to figure it out. We know that the value of that car is 10,000. Okay, so basically we have the initial value, the original value, or in other words, the present value. So let's use the formula of present value. This, so we know that the A is 10,000. Now, to pay this, right? To pay this, the buyer actually do three kind of payment. First, the down payment, and then the annuity of 500 for 14 payments, and lastly the 15th payment. That is actually not stated what is the value. That is what we need to find out. So basically it has three different kind of type of payment being made in order to pay for this car. So now basically we need to add. We already have the formula for the annuity here. So basically we need to add another two, which is the first one, which is the down payment, and then the last payment. So now that we have the formula, why not we just substitute it already. So the annuity for this case is 500. Okay, for 9% compounded monthly, so 0.09 compounded monthly. Okay, the end here is actually for 14 times. Okay, 14 times, exactly as what the question stated. Okay, so for I here is 0.09 over 12. So that is the formula for annuity for the 500 payment for 14 times. And we have next is actually the down payment. For the down payment, let's try to look back at the timeline. As you can see, the down payment is at the present value. So there is actually no discounting, no accumulating happen at this point because it is what it is, 2,000. So we just plus with 2,000. Okay. And finally, the 15th payment. What is it actually? So the 15th payment is the last payment. Okay. So we know that now, let's try to calculate it manually. So 2000 and then 500 for 14 times. So basically 500, if you pay 14 times, it is 7,000 plus with plus with 2,000, which is the down payment, it gives you 9,000. Up until now, up until the 14th point, okay, the buyer already paid 9,000. Okay, 9,000. Basically, if there is no interest, then meaning that it actually owe 1,000 more to pay for the car. But then don't forget that we have this 9% compounded monthly. Okay, initially it is 10,000, but when you pay actually not in a lump sum manner, when you pay in installment, the value should be not this. It should be greater than that. So what is actually the value of K? How do you calculate K? Okay, let's look at the timeline back. Now, for the K here, it is actually not, we cannot actually use annuity because it is a whole different value. Right? A whole different value compared to this. This 500, yes, it is annuity because it is actually an equal amount of value at an equal interval of time, as you can see here. But for the K here, it is not an annuity because it is a different value alone, and there is no interval of time, just one-time payment. So what is the value of K here? So we already calculate for the annuity. We already sum with the down payment, and what's left is the value of K. To find the value of K, we know that this is to find the value of K, right? We actually want to find the present value at this point. So basically, what we want to do is want to find the discount value of this at this point. What is the present value of the 15th payment at the present value, at our present point? So to find it, we will need to use a present formula, but not annuity. What's left is compounding formula. So instead of using annuity, right, we will use the formula of present value for compound interest. So K times with 1 plus I, which is the same as annuity, 0.09 over 12. Okay, let's try to make it bigger. Okay. And to the power of negative n. What is actually the value of n for this case, the 15th payment? Obviously 15, right? This is actually the duration, 15 months, right? So 15th, we want to look at the 15th payment. So 15. Okay, so this is the formula. Okay, so solve for K. Okay, when you calculate it, you should get K equal to 1541.96. This is the amount that need to be paid at the final 15th payment.